Welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In textile and garments production, QA acts as the guardian of product quality. This training is designed to be simple, visual, and practical, so you can apply what you learn directly in your daily work. We hope this session gives you a clear understanding of how quality assurance works in a textile and garments factory. Let's walk through the modules included in this course. Module 1. Overview of QA in Textile and Garments Manufacturing. Module 2. Leading QA operations across a factory. Module 3. Developing and updating quality SOPs. Module 4. First Time Right, or FTR, approach. Module 5. Cross-department collaboration. Module 6. Creating a strong QA framework. Module 7. Standardizing QA across multiple factories. Module 8. Planning and executing quality checks. Module 9. Pre-production and line review meetings. Module 10. Managing factory-level testing activities. Module 11. Training QA teams and improving efficiency. Module 12. Enhancing final inspection outcomes. Module 13. Sample assessments and approvals. Module 14. Material compliance checks. Module 15. Inspection documentation and archiving. Module 16. Benefits of a strong QA system. Module 17. Common QA challenges and how to overcome them. Module 18. Implementing ISO standards in the factory. If you found this video helpful, don't forget to like and subscribe. Thanks for watching, and we'll see you in modules 1 through 18. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 1. Overview of Quality Assurance in Textile and Garments Manufacturing. In this video, you will learn what is quality assurance, what is the difference between QA and QC, why QA is important in our industry, basic ideas about quality management systems, how QA works in the textile production process, a real example from the industry, a quick summary and important points, and a small exercise to check your learning. Let's begin and learn how to make better quality products together. In textile and garments production, QA is like a guardian of your product quality. It ensures that what we make matches customer expectations the first time. It's not just about checking. What is quality assurance? QA is the process of ensuring that products meet required quality standards consistently. It focuses on preventing defects before they occur, not just finding them afterward. QA is proactive, not reactive. Difference between QA and QC. Quality assurance versus quality control. QA, process-focused. QC, product-focused. QA, prevents defects. QC, detects defects. QA, proactive. QC, reactive. QA, done throughout process. QC, done after production. Think of QA as designing and following a recipe, while QC is tasting the food after cooking. Both are important, but QA gives you control before things go wrong. Why QA is important in our industry? QA helps to reduces rework, saving cost and time, increases customer satisfaction, builds a strong brand reputation, helps pass buyer audits and get repeat orders, supports compliance with regulations. Example: a factory with poor QA faced $20,000 in rework costs due to stitching defects that could have been caught early with better inline QA. Basic concepts of quality management systems. QMS is like your factory's playbook. It includes all the rules and systems that make sure quality stays high. Without it, every line might follow different standards. Key elements: standard operating procedures, documented policies and records, defined roles and responsibilities, continuous improvement plan to check act, internal audits and corrective actions. Quality assurance in the textile production flow. Steps are: 1. Raw material inspection. 2. Pre-production sample approval. 3. In-line quality checks. 4. Final product testing. 5. Final inspection and shipment approval. Real-world scenario. A buyer rejected a shipment due to poor color fastness. Investigation showed no lab testing was done before production. QA process was missing. Solution: added mandatory GPT before bulk. Trained QA team to review test reports. Set up a checklist for color fastness testing. Result: no further color fastness rejections in 3 months. Summary and key points of Module 1. QA ensures we deliver what we promise, consistently. It's about processes, not just inspection. QA reduces cost, boosts reputation, and increases buyer trust. A strong QA culture helps everyone, from operator to factory head. Thank you for joining this training session. We hope you learned something valuable. See you in Module 2. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 2, Leading QA Operations Across a Factory. In this video, you will learn the role of a QA leader, ensuring consistent execution of QMS, real-world scenario, multi-line QA supervision, leadership challenges in QA, daily QA leadership routine, QA metrics and reporting. A quick summary and important points. Let's begin and learn how to make better quality products together. A QA leader is not just a checker, they are a coach, communicator, and problem solver. Their job is to make sure quality systems are followed, not just that products are inspected. The role of a QA leader. Key responsibilities: lead and manage the QA team across departments. Ensure QMS is implemented on every production line. Monitor quality performance and take corrective actions. Report quality KPIs to management. Communicate buyer requirements to all levels. Leading with systems, not just supervision. Build a structured QA system. Train QA staff regularly. Align QA practices with production and planning departments. Create a culture where everyone feels responsible for quality. Ensuring consistent execution of QMS. Steps to ensure consistency. 1. Standardize inspection procedures. 2. Use same checklists and tools across all lines. 3. Regularly audit the QA team and processes. 4. Document all findings and share learnings. Example: a factory reduced sewing defects by 40% in 2 months after aligning all lines to a single defect classification system. Real-world scenario, multi-line QA supervision. Scenario: in a factory with 10 lines, each QA checker followed different methods. Some used handwritten notes, others used mobile checklists. Results varied. Actions taken: introduced a standardized QA checklist. Trained all inspectors on one inspection format. QA leaders conducted weekly audits. Result: defect reporting became consistent, and analysis became easier. Leadership challenges in QA. Common issues: resistance to change from production teams, miscommunication between QA and production, QA teams under pressure to pass bad quality. Solutions: train QA on soft skills and assertive communication. Conduct joint QA, production team meetings weekly. Reinforce quality goals from top management. Daily QA leadership routine. QA leadership is also about discipline. A simple daily routine can prevent big problems later. Checklist for QA leaders. Check attendance and assign QA roles. Review issues from previous day. Monitor critical areas in production. Talk to production supervisors about upcoming risk styles. Report end-of-day summary to QA manager. QA metrics and reporting. Important QA KPIs to track. First time write rate. Defect per 100 units. Rework percentage. Final inspection pass rate. QA audit score. Tip: use dashboards or simple Excel trackers to monitor trends. Quick summary. Module 2. QA leaders drive the execution of quality systems, not just inspections. Consistency, structure, and communication are key. Good leadership in QA leads to better performance, fewer defects, and a stronger factory reputation. Thank you for joining this training session. We hope you learned something valuable. See you in Module 3. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 3, Developing and Updating Quality SOPs. In this video, you will learn what is an SOP, why SOPs matter in quality assurance, what should a good quality SOP include? Example SOP. When to update a quality SOP. SOP development process. And real-world scenario. Let's begin and learn how to make better quality products together. Think of SOPs as the recipe book of your quality process. If everyone follows the same recipe, the product tastes the same every time. What is an SOP? It means a step-by-step instruction that tells how to perform a task correctly, ensures consistency, quality, and compliance. SOPs are essential for training, inspections, audits, and continuous improvement. Why SOPs matter in quality assurance? Key benefits: standardized work across teams and shifts, reduces chances of human error, makes training easier for new staff, helps comply with buyer and legal requirements, supports factory audits like ISO, buyer audits, etc. Example: one factory failed a buyer audit because visual inspection SOPs weren't documented. After standardizing SOPs, they passed the next audit with 0 nonconformities. What should a good quality SOP include? A clear SOP not only helps people understand what to do, but also why and how. Don't skip the purpose and responsibility sections. They make ownership clear. SOP include title and document code. Purpose: why the SOP exists. Scope: who and what it covers. Procedure steps: step-by-step instructions. Responsibilities: who does what. Forms or checklists used. version number and revision history, approvals and sign-off. Example SOP, fabric inspection. SOP highlights. Purpose: ensure only acceptable fabric enters production. Scope: all fabric rolls received in the warehouse. Method: 4-point system inspection. Tools: fabric inspection machine, defect tags. Records: fabric inspection report, defect classification guide. When to update a quality SOP. Triggers for SOP updates. Buyer or regulatory changes. Audit findings or corrective actions. New machinery or technology. Process improvements from root cause analysis. Staff feedback or training results. Tip: review SOPs at least once every 12 months or after a major process change. SOP development process. Involve the people who actually use the SOPs. Their feedback will make the document more practical and effective. Flowchart of SOP development process. 1. Identify need. 2. Draft SOP. 3. Review with QA or production teams. 4. Test in pilot. 5. Finalize and approve. 6. Train staff. 7. Implement. 8. Review and update. Real-world scenario. Scenario: during a customer visit, the QA team was confused about handling a poor color match in inline checks. The SOP was outdated and didn't reflect current procedures. Solution: revised the inline inspection SOP. Added color shade grading steps with visuals. Trained QA and production teams. Audited usage weekly for 1 month. Result: improved shade matching consistency and reduced shade-related rework by 35%. Quick summary of Module 3. SOPs are the backbone of your quality system. A good SOP is clear, practical, and regularly updated. Always test and train before finalizing. Use real issues from production as learning points to improve SOPs. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 4. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 4, First Time Right Approach. In this video, you will learn: what does first time right mean? Why first time right is important? How to achieve first time right in textile production? Role of QA in FTR. Real-world scenario, FTR in action. Visual tool, FTR score tracking. Tools that support first time right. Let's begin and learn how to make better quality products together. What does first time right mean? Think of FTR like cooking a dish. If you prepare it right the first time, it saves you from wasting time and ingredients fixing mistakes. First time right means doing things correctly from the beginning, no rework, no second chances. It focuses on preventing mistakes, not just detecting them. The goal: every product passes inspection the first time it's made. Why first time right is important? Saves time and cost by reducing rework and defects. Improves efficiency in production lines. Increases buyer trust and on-time deliveries. Boosts employee confidence in processes. Real example: A factory reduced rework from 18% to 6% in 3 months by introducing a first-time right mindset during needle detection and final pressing. How to achieve first-time right in textile production. Key steps. Clear tech pack review before production. Strong pre-production meetings. Use SOPs for critical processes. QA supervision during first hour of production. Root cause analysis of initial defects. Role of QA in FTR. FTR requires QA and production to work together. QA must be present early and vocal about any risks. QA responsibilities. Identify potential issues in advance. Guide the production team during pilot runs. Stop line if major non-conformities are found. Report findings immediately and help set corrective action. Real-world scenario, FTR in action. Scenario. During the first bulk run of a woven shirt, buttons were stitched too loosely. 20% of units failed the button pull test. Action taken. QA stopped the line. Button stitching SOP reviewed and reinforced. Line operator retrained. Bulk resumed with tight controls. Result. 100% pass in final inspection, no rework needed. Visual tool, FTR score tracking. Tracking FTR rate helps QA leaders identify lines or styles that need support. It's a useful KPI for daily, weekly, or monthly reporting. Sample table. Style. Shirt A. Production date. 10th April 2025. Quantity. 5,000. FTR pass rate. 94%. Remarks. Minor thread trimming issues. Style. Pants B. Production date. 12th April 2025. Quantity. 3,000. FTR pass rate. 87%. Remarks. Pocket shape variation. Tools that support first-time right. Style-specific quality checkpoints. Pilot run evaluation forms. Clear sample approval process. PP sample, size set, GPT. Line setup SOPs. Real-time quality dashboards. Quick summary, Module 4. FTR is equal to make it right the first time. It's more efficient and cost-saving than fixing mistakes later. Requires strong planning, communication, and execution. A successful FTR system reduces rework and increases buyer confidence. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 5. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 5, Cross-Department Collaboration. In this video, you will learn why cross-department collaboration matters, key departments QA must work with, common communication gaps, real-world scenario, tools for better collaboration, scheduling and sample delivery, role of QA in collaboration. Let's begin and learn how to make better quality products together. Why cross-department collaboration matters. QA is the gatekeeper of quality, but production makes the product. Procurement buys the materials, and stores manages stock. If these teams don't talk, quality suffers. Quality doesn't belong to QA alone, it's a team effort. Smooth collaboration between QA, production, procurement, and stores helps prevent delays, defects, and miscommunication. The goal: everyone works toward the same quality standards. Key departments QA must work with: production, to control quality during manufacturing; procurement, to source materials as per specs; stores, to inspect and release approved raw materials; planning, to align QA manpower with production timelines; merchandising, to understand buyer expectations and tech packs. Common communication gaps examples: production begins without approved size set; stores release fabric before inspection; procurement buys zippers from unapproved supplier; QA team unaware of urgent style changes from buyer. Result: delays, rework, and poor final quality. Scenario: delayed fabric inspection. Problem: stores received 20,000 meters of dyed fabric but didn't inform QA for inspection. Cutting started before defects were identified. Impact: 15% of garments later failed for shade variation. Solution: stores instructed to inform QA within 2 hours of receipt. Joint checklist introduced for fabric handover. Weekly coordination meeting added between QA and stores. Tools for better collaboration: daily QA, production meeting notes; sample handover tracker like Excel or app-based; joint review boards for sample and defect reviews; color-coded tags for approved or rejected materials in stores; WhatsApp or Slack groups for urgent callouts. Scheduling and sample delivery. Best practices: QA should receive samples like PP, top, GPT at least 2-3 days before need date. Use a sample calendar shared across departments. Escalate delays immediately to prevent bottlenecks. Sample table. Sample type: GPT shirt A. Expected by 15th April. Department: merch. QA received 13th April. Status: testing. Sample type: PP pants B. Expected by 18th April. Department: merch. QA received. Date not found. Status: delayed. Role of QA in collaboration. QA must be a partner, not a policeman. Quality improves when people feel like they are working together, not being watched. Clarify quality checkpoints in pre-production meetings. Share inspection results with production and merch. Help resolve quality issues, not just report them. Give feedback in a way that supports, not blames. Quick summary: Module 5. Quality is everyone's job, collaboration is the key. Align sample schedules, inspection plans, and risk styles with all departments. Use tools to track communication and avoid delays. A proactive QA team builds better cross-functional relationships. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 6. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 6, Creating a Strong QA Framework. In this video, you will learn what is a QA framework, key elements of a strong QA framework, real-world scenario, Missing QA structure. Building quality into the process. PDCA cycle. Tools for strengthening QA framework. Responsibilities across levels. What is a QA framework? A QA framework is like a building's foundation. Without it, the process becomes weak, unorganized, and risky. A QA framework is a structured system of policies, procedures, tools, and responsibilities that guide how quality is ensured at every stage of production. It ensures consistency, accountability, and continuous improvement. Key elements of a strong QA framework. Clear SOPs and work instructions. Defined roles and responsibilities. Inspection checkpoints. Corrective and preventive action plans. Training and skill development. Documentation and records. Internal audits and continuous improvement. Real-world scenario. Missing QA structure. Situation. A new production line started bulk without proper inline checkpoints. Many garments failed final inspection due to skipped stitching quality steps. What went wrong? No inline SOP shared. QA was not present at line start. Operators were not trained. Improvement steps. Created detailed QA SOP with line startup checklist. Assigned QA lead per production line. Conducted 1-hour QA refresher for all operators. Building quality into the process. A strong QA framework makes the system proactive. It's better to catch issues at the start than to fix them at the end. Proactive versus reactive. Proactive QA prevents defects. Reactive QA fixes after defect occurs. Proactive QA checks at every stage. Reactive QA relies on final inspection. Proactive QA focuses on system improvement. Reactive QA focuses on product correction. Proactive QA saves time and cost. Reactive QA causes delays and rework. PDCA cycle. A tool for continuous improvement. PDCA. Plan, do, check, act. Plan. Identify quality goals and improvement areas. Do. Implement changes or new processes. Check. Measure performance and results. Act. Standardize success or adjust failures. Tools for strengthening QA framework. Defect matrix with images for training and defect tracking. Audit schedules weekly or monthly. Corrective action tracker (CAPA). Quality control dashboards Excel or digital. Skill matrix for QA staff. Responsibilities across levels. Role. QA responsibility. QA manager develops framework, reviews performance, leads improvements. QA supervisor executes SOPs, leads inline checks, coaches inspectors. Line QA inspector performs day-to-day checks, reports defects. QA trainer trains team, evaluates skill levels, updates SOPs. Quick summary. Module 6. A QA framework is the system that holds quality together. It must include SOPs, checkpoints, training, and reviews. Use tools like PDCA, defect matrices, and audit schedules. Everyone has a role in maintaining the QA structure. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 7. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 7, Standardizing QA across multiple factories. In this video, you will learn why standardization is important, common problems without QA standardization, what needs to be standardized, example, standard defect classification, real-world scenario, tools to support QA standardization, role of QA leadership. Why standardization is important. Buyers expect the same quality from all units. Standardization helps us deliver that, no matter who is working or where it's made. Different factories often have different people, machines, and workflows. Without standardization, quality results vary from one unit to another. Standard QA processes help maintain buyer trust, brand reputation, and cost control. Common problems without QA standardization. One factory checks 100% of garments, another checks only 20%. Different defect classification systems confuse reporting. SOPs vary from unit to unit. Training quality differs across locations. Impact. Inconsistent final inspections, uneven quality, increased buyer complaints. What needs to be standardized? SOPs for all QA processes. Defect classification and terminology. Inspection formats and reporting templates. Training content for QA staff. Quality KPIs and performance dashboards. Audit and review schedules. Sample approval procedures. Example, standard defect classification. Defect type. Stitch skip. Code. ST01. Description. Missing stitches in seam. Defect type. Shade variation. Code. CL02. Description. Uneven color in garment panel. Defect type. Open seam. Code. ST05. Description. Seam not secured, may come apart. Scenario. Without standard codes, factory A reports stitch gap. Factory B says missing stitch. A shared defect matrix solves this. Real-world scenario. Inconsistent inspection format. Problem. Factory X uses handwritten reports. Factory Y uses Excel. Factory Z reports by phone. Buyer audit found poor tracking and inconsistent quality data. Solution. Introduced a shared digital inspection format. All factories trained to use the same reporting terms. Monthly QA audits to review report accuracy. Tools to support QA standardization. Master SOP manual shared across factories. Digital QA dashboard for all units. Centralized QA training calendar. Shared inspection report templates. Monthly QA review meetings with factory heads. Role of QA leadership. QA leadership is like a coach. Everyone must follow the same playbook to win. What QA leaders must do? Align all units under one system. Train factory QA heads on the same guidelines. Audit all factories regularly. Share best practices between locations. Monitor KPIs across all units. Quick summary of Module 7. Without standard QA systems, quality will vary. Use one set of SOPs, reporting tools, and training systems. Leadership must review and enforce the standards. Consistency builds confidence with buyers and management. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 8. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 8, Planning and Executing Quality Checks. In this video, you will learn what is a quality check, why planning is critical, sample quality check plan, visual inspection aids, inline inspection example, final inspection checklist example, common pitfalls in QA execution. What is a quality check? Each check acts like a safety net. If done correctly and on time, they prevent problems from reaching the customer. Definition: a quality check is a planned inspection of materials, processes, or finished products to make sure they meet defined standards. Types of checks in textile garment industry. 1. Raw material inspection, example fabric, trims. 2. In-process or inline inspection. 3. Final inspection, before packing or shipment. Why planning is critical. Ensures inspections happen on time. Makes sure QA teams are available where needed. Helps prioritize risk styles and urgent orders. Avoids last-minute inspections and shipment delays. Sample quality check plan. Inspection type: fabric inspection. Responsible: QA and stores. When to perform: within 24 hours of fabric arrival. Tools needed: fabric inspection SOP. Inspection type: inline check. Responsible: line QA. When to perform: first hour plus hourly intervals. Tools needed: defect sheet, measuring tape. Inspection type: final inspection. Responsible: QA lead. When to perform: 100% before packing starts. Tools needed: final checklist, buyer spec sheet. Visual inspection aids. Tools help make decisions easier and faster, especially for new inspectors. Checklists for each inspection stage. Color-coded tags: pass, hold, reject. Defect reference cards with photos. Measuring tools: tapes, scales, GSM cutters. Mobile apps or tablets for digital inspections. Inline inspection example. Scenario: QA performs an hourly check on a trouser line. They find 12% of units have seam puckering. Actions taken: QA alerts line supervisor. Machine settings checked and adjusted. Retraining done for 2 operators. Defects reduced to 2% in next hour. Final inspection checklist example. Checklist includes stitch quality, measurement specs, label and packaging accuracy, color and shade match, cleanliness and presentation. Tip: use AQL method for final inspection sampling. Common pitfalls in QA execution. Skipping checks due to time pressure. Incomplete documentation. QA team unaware of latest buyer requirements. No action taken after defect discovery. Solutions: share daily QA plan with all teams. Train on updated buyer specs. Regularly review checklists and logs. Quick summary: Module 8. Plan inspections in advance and assign responsibility. Perform quality checks at all key stages. Use proper tools and documentation. Take immediate action when defects are found. Consistent QA execution is equal to fewer reworks and higher buyer satisfaction. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 9. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 9, Pre-Production and Line Review Meetings. In this video, you will learn what is a pre-production meeting, who should attend a PPM, key topics covered in PPM, example, PPM discussion points, what is a line review meeting, real-world scenario, tools to use in PPM and line reviews. What is a pre-production meeting? Think of it as the kickoff for bulk. If this meeting is skipped or weak, problems are likely to show up during production. Definition: a pre-production meeting is held before bulk production starts. Its purpose is to align all departments, QA, production, merchandising, etc. Discuss style-specific requirements. Identify potential risks. Plan preventive actions. Who should attend a PPM? QA manager, QA team lead. Production manager, line supervisor. Merchandiser, buyer representative. IE team. Cutting and finishing in charge. Fabric trim store personnel. Key topics covered in PPM: buyer's quality standards, technical file review, measurement, construction, specs, sample approvals, size set, PP sample, etc. Critical operations, embroidery, washing, printing, defect prevention plan, testing and inspection schedules. Any learnings from past styles. Example, PPM discussion points for a polo shirt. Topic, notes. Fabric by cotton, confirm shrinkage test passed. Print chest logo, confirm registration and fastness. Construction collar attachment often shows puckering, adjust SPI. Packing fold method updated, new polybag size approved. What is a line review meeting? This is like a health check at the start of bulk production. It ensures everything is ready and working correctly. Definition: a line review happens when production starts. QA, production, and IE teams walk the line together. Check machine setup and operator skill. Review the first output. Verify that PPM instructions were followed. Real-world scenario, skipped PPM consequences. Situation: a factory skips PPM due to time pressure. Bulk stitching starts. After 2000 PCs, buyer finds incorrect collar shape and rejects the lot. Lessons: no review of PP sample. Construction change not communicated. Preventive action missed. Result: rework, shipment delay, and buyer complaint. Tools to use in PPM and line reviews. PPM checklist, customized by buyer style. Tech pack printouts. Approved sample reference. Skill matrix of operators. Initial QA report format. Photos of critical operations. Quick summary, Module 9. PPMs and line reviews are essential for quality planning. They prevent issues before bulk starts. All departments must align on expectations. Use proper checklists and review critical points. Always document meeting outcomes. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 10. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about why factory-level testing matters, what testing is done at factory level, in-house testing versus third-party labs, setting up an in-house test lab, case study, color fastness testing, managing test documentation, lab accreditation and buyer compliance, challenges in factory testing. Factory-level testing is not just a requirement, it's a quality gate. It helps us solve problems internally, faster and cheaper. Why factory-level testing matters? Confirms product safety and quality before buyer review. Helps detect problems early, color fastness, strength. Reduces dependence on third-party labs for all tests. Builds buyer confidence in factory capabilities. What testing is done at factory level? Common in-house tests in textiles. GSM grams per square meter, fabric weight. Color fastness to wash, rub, light etc. Seam strength, shrinkage after washing, tear and tensile strength, button snap pull test. In-house testing versus third-party labs. Feature: in-house testing, third-party labs. Speed: fast same day, slower 1 to 3 days. Cost: low internal, high per test. Buyer acceptance may vary, usually accepted. Control: high, low. Best practice: use in-house tests for quick screening and repeat tests. Use third-party labs for final buyer-required reports. Setting up an in-house test lab. Key requirements: 1. Trained QA technicians. 2. Calibrated equipment GS marketer, crockmeter, tensile tester. 3. Standard operating procedures. 4. Testing protocols as per buyer ISO ASTM standards. 5. Sample retention system for traceability. Case study, color fastness testing. Scenario: buyer rejects shipment due to color bleeding in wash test. Actions taken: factory sets up crocking and wash test in-house. SOP created using ISO 105 standards. QA performs tests on all batches before sewing starts. Result: color fastness issues caught early, no more rejections. Managing test documentation. Maintain test logs and registers. Archive test results with date, batch, sample ID. Store tested samples for 6-12 months. Include test results in QA reports for production and buyers. Visual idea: show a sample test report format. Lab accreditation and buyer compliance. Why accreditation matters? Proves lab follows proper standards. Helps get buyer approval for in-house testing. Improves trust and audit readiness. Example accreditation types: ISO 17025 for testing labs. Buyer-specific certifications: Walmart, Target, Decathlon lab approval. Challenges in factory testing. Machine calibration errors. Lack of trained personnel. Test result variation. Miscommunication of test limits. Solutions: monthly calibration log. Regular technician training. Display pass-fail criteria clearly. Cross-check random results with external labs. Quick summary, Module 10. In-house testing ensures product meets quality specs. Factory labs save time and reduce rework cost. Test labs need trained staff, proper equipment, and SOPs. Document and archive all test results. Accreditation improves trust with buyers. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 11, Training QA Teams and Improving Efficiency. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 11, Training QA Teams and Improving Efficiency. In this video, you will learn why training QA teams is important. What should QA teams be trained on? Real-world training scenario. Methods to train QA teams. Sample tools for QA training. Improving efficiency with technology. Measuring training impact. Why training QA teams is important. A well-trained QA team is the backbone of any quality system. Training reduces mistakes and builds a culture of continuous improvement. Ensures consistent understanding of quality standards. Reduces inspection errors and missed defects. Increases speed and confidence in decision-making. Prepares QA for buyer audits and product evaluations. What should QA teams be trained on? 1. Defect identification and classification. Stains color shading versus misprint. 2. Inspection procedures. Inline, final, AQL-based, sampling method. 3. Buyer-specific requirements. Measurement tolerances, label position, packaging. 4. SOP knowledge. Fabric inspection, trim checking, test protocols. 5. Using tools and machines. Lightbox, GSM cutter, test equipment, software apps. Real-world training scenario. Issue. QA team at a knitwear factory misclassified stitch skipping as a minor defect. Result. Buyer returned 15,000 pieces due to visible stitch issues. Action taken. QA manager held refresher training using defect photos and buyer standards. A printed defect classification chart was placed at all QA stations. Outcome. Defect detection rate improved in next audit. 98% pass rate. Methods to train QA teams. Classroom training, using SOPs, buyer manuals, videos. On-the-job coaching, walking lines, live defect identification. Mock inspections, practicing final audits on sample pieces. Shadowing, junior QA follows senior for real inspections. Monthly refresher programs, to keep knowledge updated. Sample tools for QA training. Defect photo catalog flipbook. Videos of good versus bad quality stitching. Real garment samples with intentional defects. Printed SOPs in local language. Laminated pocket cards. Inspection tips, buyer specs. Improving efficiency with technology. Use mobile apps to record inspection results. Digital checklist instead of paper. Auto alerts for defect trend spikes. Real-time dashboards for production lines. Barcode scanning for sample tracking. Example. Using a tablet to log inline defects saves 30 minutes per shift per inspector. Measuring training impact. KPIs to monitor. First time right percent. Final inspection pass rate. Audit failure reasons. Inspector error reports. Training attendance and test scores. Tip. Set goals and track progress monthly. Reduce QA errors by 25% in 3 months. Quick summary, Module 11. Regular training keeps QA teams sharp and consistent. Mix classroom plus practical training for best results. Use visuals and real garment samples in training. Train QA on buyer specs and SOPs. Measure and improve team efficiency with digital tools. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 12, Enhancing Final Inspection Outcomes. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 12, Enhancing Final Inspection Outcomes. In this video, you will learn what is final inspection, when to conduct final inspection, key checks in final inspection, using AQL in final inspections, real factory scenario, best practices to improve final inspections, sample final inspection checklist, what buyers look for in final QA. What is final inspection? Definition: final inspection is the last QA step before shipment. It checks if finished products meet buyer specifications and are free from defects. Main goals: verify product quality, ensure correct packing, labeling, and documentation, confirm quantity and assortment, prevent rejections and returns. When to conduct final inspection? When at least 80% of the shipment is packed, prior to buyer QC visit or internal approval, after finishing and packing is completed, before issuing the final inspection certificate. Key checks in final inspection. A final inspection is like a dress rehearsal. Everything should be perfect, just as the buyer expects. Checkpoint: description, workmanship, stitching, print, embroidery, trims, measurement, sample pieces checked against size spec, color appearance, shade matching, dirt, all marks, labeling, tagging, correct barcode, style, size, care labels, packing, folding, polybag, carton quality, assortment, sizes, colors, quantity breakdown. Using AQL in final inspections. AQL is a statistical tool to decide if a shipment passes or fails. Common AQL levels: 2.5, 1.5, 4.0. Sample size based on shipment quantity. Example: for 1,200 PCs at AQL 2.5, sample 80 PCs. Accept 5 defects, reject if 6 or more. Real factory scenario: failed final inspection. Issue: buyer rejected shipment due to open seams and wrong tag on some garments. Investigation: no inline check after stitching. Packing team used old label format. Final inspector missed tag issue due to workload. Corrective action: retrained inspectors on tag specs. Added inline QC step post stitching. Introduced cross-check step during packing. Best practices to improve final inspections. Always use buyer-approved specs and samples. Use defect classification guide. Follow a standard inspection checklist. Have trained and fresh QA team conduct inspections. Use digital tools to log and report findings. Sample final inspection checklist. 1. Workmanship. 2. Label, correct style, barcode. 3. Size spec, plus, tolerance. 4. Shade match, visual light box. 5. Packing, clean, no damage. 6. Assortment, color size verified. 7. Quantity, counted cartons versus invoice. What buyers look for in final QA. Consistency with approved sample. Product meets all promised features. Neat, clean, and safe packaging. No major or critical defects. On-time inspection scheduling. Transparent documentation. Quick summary, Module 12. Final inspection is your last line of defense. AQL helps make fair pass-fail decisions. Always align checks with buyer expectations. Use checklist and trained team. Fix problems upstream. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 13, Sample Assessments and Approvals. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 13, Sample Assessments and Approvals. In this video, you will learn why are sample assessments important, common sample types in garment manufacturing, lab dip and shade blanket assessment, size set evaluation, top of production samples, GPT, garment performance testing, PP sample, sample approval workflow, sample evaluation report, real case, rejected size set, key tips for smooth sample approvals. A single rejected sample can delay production. Getting it right saves time, money, and your reputation. Why are sample assessments important? Buyers use samples to approve product quality before allowing mass production. Samples ensure the final product matches design, fit, quality, and functionality. Avoids bulk rejections by identifying issues early. Common sample types in garment manufacturing. Sample type. Purpose. Lab dip shade blanket. Approve fabric color accuracy in different lighting. Size set. Approve fit and measurements across all sizes. Top. Confirm bulk matches approved sample. GPT. Approve wash, shrinkage, color fastness, etc. Pre-production. Sample approve final construction, trims, and styling details. Lab dip and shade blanket assessment. Compares bulk fabric color to buyer-approved shade. Evaluated under different lights, daylight, TL84, UV. Use light box for accuracy. Example. Fabric submitted appears blue under TL84, but greenish in daylight rejected. Tip. Submit 3-4 shade options for faster buyer approval. Size set evaluation. Checks measurements for all garment sizes XS to XXL. Ensures shrinkage, fit, and tolerance within buyer standards. Example issue. M size t-shirt length is 2.5 cm shorter than spec. Buyer may reject full size set. Corrective action. Adjust pattern before cutting bulk. Top of production samples. Pulled from actual bulk production. Confirms the factory followed all approved materials, trims, workmanship. Must be sent early around 30%, 50% production done. Checklist. Correct shade. Stitching and trims. Labels and tags. Overall presentation. GPT, garment performance testing. Tests for wash fastness, shrinkage, color bleeding, seam strength. Done in-house or via third-party labs. Required by many international buyers, Walmart, Target, H&M. Real example. GPT fail due to 6% shrinkage limit is 3%. Bulk cannot proceed until resolved. PP sample. Final reference for factory workers. Must include all final details. Labels, accessories, stitching style. Approved PP sample must be sealed and stored in production area. Sample approval workflow. 1. Sample created by production or merchandising team. 2. QA team inspects sample against buyer specs. 3. Corrections made if needed. 4. Final sample submitted to buyer. 5. Buyer gives feedback, approve or reject. 6. Approved sample is sealed and used as standard. Sample evaluation report. Fields to include: style hush, sample type, measurements with tolerance check, color comments, trim quality, workmanship, defects observed, approval status, approved, rejected, rework. Real case, rejected size set. Factory, woven shirt unit. Issue, sleeves too tight in L and XL sizes. Root cause, incorrect grading during pattern development. Action taken, regraded pattern, submitted revised set approved. Key tips for smooth sample approvals. Follow buyer tech packs strictly. Maintain strong coordination between QA, production, and merchandising. Keep sample records and feedback properly filed. Always check sample before sending to buyer. Use checklists during internal sample review. Quick summary, Module 13. Sample approval prevents bulk quality issues. Different sample types serve different purposes. QA plays a critical role in checking, verifying, and improving samples. Delayed or poor quality samples is equal to delayed production and higher cost. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 14, Material Compliance Checks. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 14, Material Compliance Checks. In this video, you will learn what is material compliance, types of incoming materials, common buyer requirements, material inspection methods, real factory scenario, documentation for material compliance, material rejection handling, compliance checklist, key tips for material compliance. What is material compliance? Material compliance is a crucial step in garment manufacturing. It ensures that everything we bring into the factory from fabric to packaging meets buyer requirements and legal safety standards. It's not just about quality, it's about preventing potential product recalls, safety hazards, and buyer dissatisfaction. Our goal is to ensure all materials are safe, functional, and approved before use in production. Types of incoming materials. Let's look at the 5 main categories of incoming materials. Each of these has different compliance requirements. Fabrics can vary from knits to denim. Trims include functional elements such as zippers and buttons. Labels and tags need to be accurate. Packaging materials protect the product during shipping and transportation. Accessories like sequins or patches often carry safety risks. All of them must be reviewed for compliance before use. Common buyer requirements. Buyers have specific quality and safety standards. These can include color fastness to avoid bleeding during washing, control over shrinkage, and strong stitching components. Importantly, safety and regulatory standards, like REACH in Europe or CPSIA in the US, must be met to avoid legal issues. Every incoming material must comply with these buyer-specific expectations. Material inspection methods. Different materials need different inspection techniques. Fabric is typically checked using the 4-point system, which identifies and rates defects. Trims must be tested for function and safety, zippers must work smoothly, and metal parts shouldn't be sharp. Labels are verified for correct information and barcode functionality. Each step ensures the item is both functional and compliant. Real factory scenario: button rejection. Here's a real-life example. During routine inspection, a sharp-edged metal button was found. This posed a serious safety risk and could have led to customer injury or buyer complaints. Immediate action was taken, production was stopped, the button batch returned, and we implemented 100% testing for sharp edges moving forward. This example shows how proper inspection can prevent major issues. Documentation for material compliance. Proper documentation is key to traceability and accountability. The material inspection report logs what was checked and the results. Lab test reports provide performance and chemical safety data. Approval forms or counter samples signed by the buyer or QA head serve as the final reference. These records must be kept for 6 to 12 months in case of audits or issues. Material rejection handling. If a material fails inspection, it must be tagged and isolated immediately to prevent accidental use. The supplier should be informed with documented evidence. The batch can be returned or replaced, but it must not be used until it's cleared by the QA manager. To avoid production delays, it's always smart to keep buffer stock of approved trims. Compliance checklist. This visual checklist summarizes key material compliance checks. Make sure fabric matches approved shade and width. Look for defects using the 4-point system. Verify trims for size, color, and function. Labels must be accurate. Safety tests must be passed. And, of course, keep all the documentation up to date. This checklist helps ensure nothing is missed. Key tips for material compliance. Here are some tips for day-to-day compliance. Critical items like safety-related trims or labels should be inspected 100%. For fabric, inspect at least 10% of the bulk. Always compare against the buyer-approved counter sample. Use tools like measuring tapes, lightbox, and structured checklists. Finally, log everything daily and report any rejections promptly. Quick summary, Module 14. To wrap up, material compliance protects both the brand and the end consumer. Never skip material checks before accepting into stores. QA must work closely with stores and purchasing teams. And remember, documented inspections can prevent expensive rework and complaints later. Material compliance is not just a formality, it's a quality and safety shield. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 15, Inspection Documentation and Archiving.
Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 15, Inspection Documentation and Archiving. In this video, you will learn why documentation matters in QA, key QA documents to maintain, sample inspection report format, archiving best practices, digital record-keeping tools, real factory scenario, missing inspection report, document review checklist, how QA documentation helps continuous improvement. Why documentation matters in QA. Let's start with why documentation is so important in quality assurance. Proper documentation serves as proof of inspection and compliance, supporting you during internal and buyer audits, regulatory checks, and when resolving customer complaints. It also helps identify repeating quality issues so teams can take corrective action. Good documentation improves communication across departments and provides legal and regulatory protection in case of disputes. Key QA documents to maintain. Here are the core QA documents every garments facility should maintain. Inspection reports, document defects found, actions taken, and pass-fail decisions. Sample approval forms, records of buyer approvals for PP, top, or size sets. Lab test reports, results from shrinkage, color fastness, or safety testing. Audit reports, internal or external audits of your QA processes. Training records, proof that QA staff have been properly trained. Material inspection reports, results of incoming fabric and trim inspections. Keeping these up to date ensures accountability and smooth operations. Sample inspection report format. This slide shows what a standard inspection report might look like. You'll notice key fields such as style number, inspection type, date, and inspector's name, the sample size and any defects found, a clear result, pass or fail, and final remarks. Such structured reports provide consistency and make audits much easier to manage. Archiving best practices. Archiving is just as important as creating the report. Use both physical folders and digital formats like Excel or Google Drive. Always label documents clearly by style number, PO, and date. Use a standard naming format like StyleNo PO type inspection type date.pdf. As for retention, keep records for 6 to 12 months for regular orders. For compliance-sensitive buyers, retain documents for at least 2 years. These practices help with traceability and protect your factory during audits. Digital record-keeping tools. There are great tools to manage QA records digitally. Excel or Google Sheets, easy to update and customize. ERP systems, these integrate with production and store records automatically. Cloud storage, Dropbox or Google Drive makes documents easy to access and reduces paper. QA software offers dashboards, tracking, and analytics for inspection trends. Using these tools enhances efficiency and transparency. Real factory scenario, missing inspection report. Let's look at a real-world example. A buyer's audit team visited a factory and requested a top inspection report from 3 months earlier. Unfortunately, the report was missing due to poor archiving. The factory received a non-compliance note, and the buyer's trust was shaken. The lesson here? Always back up your QA files and assign someone responsible for archiving. Document review checklist. Before archiving any report, use this quick checklist. Are all fields filled? Date, inspector, findings? Are there signatures from QA and supervisor? Are photos attached? If needed? Have actions on rejections been noted? Is the document stored properly? This checklist helps prevent errors and prepares your documents for any future review. How QA documentation helps continuous improvement. Documentation isn't just about record keeping. It drives continuous improvement. You can track data over time and spot recurring issues. Use reports for root cause analysis. Real inspection reports serve as great training material.
It also builds buyer trust by showing transparency. Think of your documents as tools to make your processes smarter and more reliable. Quick summary, Module 15. Documentation is essential for QA success. It supports audits, buyer approvals, and training. Use clear formats and consistent archiving methods. Maintain both digital and physical records when possible. Assign a QA coordinator or admin to oversee record keeping. By doing these, your QA system will run smoother and gain buyer confidence. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 16, Benefits of a Strong Quality Assurance System. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 16, Benefits of a Strong Quality Assurance System. In this video, you will learn what is a strong QA system, key benefits of a strong QA system, factory scenario, quality is equal to cost saving, key QA KPIs, how QA builds buyer trust, real-life brand example, why QA matters. What is a strong QA system? A strong QA system is more than just doing a final inspection. It includes quality checks at every stage, from raw material to final packaging, trained staff who follow standard operating procedures, proper documentation and inspection reporting, corrective and preventive action processes, also known as CAPA, and importantly, strong communication across departments. This creates a consistent system where quality is built into the process, not inspected in at the end. Key benefits of a strong QA system. A well-established QA system provides multiple advantages. Fewer defects by identifying problems early. Right first-time production, reducing rework and wastage. Buyer confidence, consistent quality builds trust. Cost savings, fewer rejections and compensation claims. Audit readiness, ensures you are prepared for any buyer or certification audit. Team accountability, everyone knows their role in maintaining quality. Improved reputation, consistent quality boosts your brand image. These are not just operational benefits, they directly impact business growth. Factory scenario cost saving through QA. Let's look at a real factory example. Before strengthening QA, the factory had an 18% rejection rate and frequent buyer complaints. After implementing SOPs and training the QA team, the defect rate dropped to just 5%. This led to improved buyer satisfaction, and repeat orders nearly doubled. This shows how investing in QA directly improves financial performance and customer relationships. Quality is equal to cost saving. Quality assurance is not just a cost, it's a way to save cost. Without QA, rework consumes time, labor, and materials. Rejected shipments result in revenue loss. Buyer complaints can lead to penalties or cancelled orders. With a strong QA system, defects are reduced. Deliveries are on time. Factory efficiency increases. And you gain stronger bargaining power with buyers. Key QA KPIs. To monitor the effectiveness of your QA system, here are the KPIs to track. Final inspection pass rate shows how often products meet standards without rework. Rework ratio indicates production inefficiency. First-time pass rate reflects the quality of initial production. Inline defects per 100 pieces helps catch issues early in the process. Audit score measures how well your factory performs during buyer or ISO audits. These indicators help drive improvement and accountability. How QA builds buyer trust. A strong QA system shows your commitment to consistency and transparency. When buyers see documented QA processes and inspection reports, they feel more confident sourcing from your factory. They are more likely to place long-term and higher-value orders. QA builds not just product quality, but also business relationships. Real-life brand example: why QA matters. Here's a case from a well-known global sportswear brand. A full shipment was rejected due to inconsistent fabric color. The root cause was traced back to a missing SOP and lack of material approval. The factory responded by implementing a proper QA framework. Within 6 months, the brand resumed orders. This example shows how one weak link in the QA chain can damage relationships, but also how corrective action can rebuild trust. Quick summary: Module 16. A strong QA system is not just about inspections, it builds a stronger business. Helps reduce costs, defects, and customer complaints. Increases efficiency and buyer trust. Key to scaling your factory for larger, more valuable orders. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 17, Common QA Challenges and How to Overcome Them. Hello, and welcome to our training series on Quality Assurance in Textile and Garments Manufacturing. In today's video, we will talk about Module 17, Common QA Challenges and How to Overcome Them. In this video, you will learn why challenges happen in QA. Challenge 1, Miscommunication between departments. Challenge 2, Time pressure and missed inspections. Challenge 3, Lack of training. Challenge 4, No standardized defect classification. Challenge 5, Resistance to QA processes. Challenge 6, Inconsistent QA across multiple units. Challenge 7, Lack of root cause analysis. Why challenges happen in QA. Fast production timelines. High volume orders. Inconsistent supplier quality. Miscommunication between departments. Lack of training and unclear SOPs. Resistance to change in factory processes. Challenge 1, Miscommunication between departments. Example: QA team finds fabric defect during inspection. Production says they were not informed earlier. Delay and blame follow. Solution: use a cross-department checklist. Conduct daily QA production huddles. Share SOPs and inspection results in real time. Challenge 2, Time pressure and missed inspections. Example: due to tight shipment deadlines, inline inspections are skipped. Final inspection reveals major stitching errors. Solution: integrate QA into production plan. Set buffer time for each quality check. Prioritize critical to quality points in fast-track orders. Challenge 3, Lack of training. Example: new line inspectors fail to identify puckering issue in collars. 300 pieces have to be reworked after final inspection. Solution: regular QA training using real garment samples. Use visual guides for defect categories. Pair new inspectors with experienced QA staff. Challenge 4, No standardized defect classification. Example: different QA inspectors mark the same sewing issue with different defect codes. Reports become confusing. Solution: create a standard defect classification manual. Conduct monthly review meetings to align all inspectors. Use photographs for each defect type. Challenge 5: resistance to QA processes. Example: line supervisors see QA as slowing down production and sometimes ignore inline checklists. Solution: train supervisors on the business value of QA. Involve production team in root cause analysis. Reward lines with high first-time pass rates. Challenge 6: inconsistent QA across multiple units. Example: Factory A uses strict shrinkage testing. Factory B does not. Final product quality varies between units. Solution: standardize all SOPs across units. Share test templates and equipment calibration methods. Assign QA coordinators to monitor factory-to-factory consistency. Challenge 7: lack of root cause analysis. Example: same sleeve twisting issue appears every month. Only temporary solutions are applied. Solution: use 5 whys or fishbone diagrams to analyze problems deeply. Focus on prevention, not correction. Create a corrective action logbook reviewed weekly. Quick summary: Module 17. Every factory faces challenges. Good QA teams solve and learn from them. Effective QA requires communication, training, and teamwork. Use standard processes and visual tools to reduce confusion. Address root causes instead of treating symptoms. Collaboration with all departments is key to sustainable quality. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update. See you in Module 18, Implementing ISO Standards in the Factory. Hello, and welcome to our training series on Quality Assurance in Textile and Garment Manufacturing. Today, we are diving into Module 18, Implementing ISO Standards in the Factory. In this session, you'll learn what ISO is and why it matters, a closer look at ISO 9001, the most relevant quality management standard, how to implement ISO step by step in your factory, real-life success stories and common mistakes to avoid. Let's get started. This module is all about implementing ISO standards in a practical, step-by-step way. We'll show you how to align your quality systems with ISO 9001 and other international standards to build stronger, more reliable operations. What is ISO? ISO stands for the International Organization for Standardization. It develops globally recognized standards to ensure quality, safety, and efficiency in all types of industries. In textile and garment factories, the most common ISO standards are ISO 9001, focused on quality management systems. ISO 14001, related to environmental impact. ISO 45001, covers health and safety at the workplace. Why ISO is important for factories. Implementing ISO standards brings multiple benefits to your factory. It proves to buyers and partners that your factory meets international quality expectations. It increases consistency and customer satisfaction. It helps you manage risks and comply with regulations. It prepares you for audits. And it enhances your credibility and competitive edge in the market. Focus on ISO 9001, Quality Management System. Among all the ISO standards, ISO 9001 is the most relevant for quality assurance teams. It's about more than just inspections. ISO 9001 is a complete system for understanding and meeting customer requirements, documenting and improving every process, and consistently measuring and enhancing performance. Its core principle is: say what you do what you say, and prove it. Key elements of ISO 9001 in Garment QA. Let's break ISO 9001 into 6 key elements from a QA perspective. Leadership. QA leaders must drive the ISO implementation. Planning. Set clear quality goals and monitor them. Support. Provide tools, training, and clear SOPs. Operation. QA must be part of the production plan, not separate. Performance evaluation. Use KPIs, audits, and data. Improvement. Solve root problems with CAPA and regular updates. These elements ensure quality becomes part of your everyday operations. Step by step, how to implement ISO 9001 in a factory. Here's a practical 6-step plan to implement ISO 9001 in your factory. 1. Understand the standard. Train QA leads on ISO 9001 structure. 2. Gap assessment. Compare your current practices to ISO requirements. 3. Create documentation. Write SOPs, policies, and manuals. 4. Train all staff. Everyone must understand their QA role. 5. Internal audits. Regular checks to see if processes meet the standard. 6. Get certified. Hire a recognized certification body to audit and approve. Real factory example, ISO 9001 journey. Here's a real story from a knitwear exporter. Before ISO, they had no clear responsibilities, no quality targets, high defect rates. After implementing ISO, they developed a full QA manual, trained the team and ran monthly reviews. Defect rate dropped from 9% to 3%. Buyers became more confident and orders increased. This shows how ISO creates measurable improvements. ISO documentation must-have list. Documentation is a big part of ISO. Here are the must-haves. Quality manual describes your entire QA system. SOPs, clear instructions for each QA task. Corrective action log tracks problems and fixes. Training records shows your team is qualified. Inspection reports, evidence of checks and decisions. Audit reports, internal reviews of your performance. Proper documentation is your proof of compliance and improvement. Common mistakes during ISO implementation. Let's talk about what not to do during ISO implementation. Don't rush certification, train your team first. Don't copy SOPs from others, customize them to your factory. Don't exclude the production team, everyone must be involved. Don't ignore audit findings, follow up and close the loop. And remember, ISO is not a one-time event. It's about building a habit of continuous improvement. Quick summary, Module 18. ISO 9001 helps your factory grow with quality and confidence. Involves planning, documentation, training, and audits. QA team plays a central role in success. It builds a culture of consistency and improvement. Thank you for joining this training session. We hope you learned something valuable. Don't forget to like, subscribe, and hit the bell so you never miss an update.